Okay, now I'm going to talk about confidence intervals, which is another area where students very often get pretty confused. I just want to pause for a second and say that remember how when I was talking before about how your observed value is going to be a composite of the true value that the person should have plus some amount of error, and that's always true, that we can never say with certainty that we see the true value. We can only say what we observed, and we know that there's always going to be some element of error in what we observe. And let's take an example where we have a person who achieved a score of 70 on a test, okay? So x equals 70, and we know that the standard error is 10 from our calculations that we've done. Now the mean score of the test is 50, and we want to answer the question, what numbers do we have to put for this person's true score in order to be 95% sure that we're right? If we say that this person's true score is 70, then that's what we actually saw, but we can't be absolutely sure that we're right because of the error that clouds our ability to see this person's true underlying ability or what have you. So we know that there's a standard error of 10. And now going back to the normal curve, when you take 1.96 standard deviations above the mean and below the mean, you end up cutting off 95% of the total curve. And so if a person gets a score of 70, then, and if the standard error is 10, then we know with 68% certainty, or you could say with a 68% confidence interval, that their score is between 60 and 80. But if we want to be 95% sure that we're right, then we'll say that their score is actually between, and more or less now, I mean, it's actually, this would actually be not exactly 50, it would be a little bit over 50, but I'm just going to say 50 and 90. What we would actually do is multiply 10 by 1.96 and add it to 70, so we would actually say that their score would be 89.6, but I think 90 is close enough for what we're doing. Okay, so so in this example that I'm giving, we're 95% sure that this person's true score is between 50 and 90, given that we observed them to get a score of 70 and our standard error is 10. Now, you might be wondering, well, but the mean score for the test is 50. Yes, that's for everybody, but what we're doing is building a confidence interval around this particular person's score, so the mean score on the test is not applicable to calculating the confidence interval for their score. Okay, let me say a few other things about confidence intervals. If you want to be more sure that you're accurate when you're reporting a confidence interval, then your confidence interval is going to get bigger, right? Because the bigger range you say, the more likely you are to have their true score fall between those two numbers. So if you can only tolerate a 5% chance of being wrong, you're going to have a huge confidence interval. If you can tolerate a 50% chance of being wrong, you can have a smaller confidence interval around their actual score. Remember that when your standard error is bigger, your confidence interval will also get bigger, because the confidence interval is calculated based upon the standard error. So the bigger your standard error, the bigger your confidence interval. And finally, as I was talking about earlier, if you have a bigger sample size, that actually decreases your standard error. And that leads to a narrower confidence interval. So the bigger sample size you have, the narrower your confidence interval is going to be. And this is another sort of tricky thing for students to grasp. Don't feel bad if you're not understanding this right away. But let me see if I can say it very simply. The confidence interval is named the confidence interval because we're saying we are confident that the score is between here and here. Our actual observed score is going to be in the middle of that. And the bigger the range, the more confident we get, but the less precise. Because if I wanted to guess someone's weight, and I said, I think you weigh 100 pounds, but my confidence interval is 30 pounds, so I'm 95% sure you're between 70 and 130, that wouldn't be that impressive in terms of my ability to say how much you weigh. But if I made that confidence interval smaller, I'd be more likely to be wrong, but I think my prediction would seem more useful because it would be a smaller range. Okay, that's confidence interval.